4.99. So here they're asking us to arrange the following isoelectronic species. What does that mean? Right, they have the same number of electrons, same electron configuration, in order of increasing ionization energy. So if they're isoelectronic, they should have the exact same shielding. They have the same number of electrons, so they should experience the same amount of shielding. So if we're trying to look at their ionization energy, the factors that affected ionization energy were noble gas configuration, and we said that only affects some of the elements. If we're removing an electron to look at ionization energy, it's only going to be affected by the noble gas configuration if the element already has a noble gas configuration exactly, or will make a noble gas configuration exactly. So if it's not either of those, if it's somewhere else on the periodic table where removing an electron doesn't affect anything related to the noble gas configuration, we skip over that factor, go to the next factor, which is the shielding. Then the other factors are the number of protons, and probably similar in importance to that is whether or not we have a half full or full subshell. So this factor, and this factor are all determined by how many electrons we have and where those electrons are located, what energy levels and subshells they're in. So if we have elements that are isoelectronic and they all have the same number of electrons, they all have to be either a noble gas configuration or not. That's not going to help me distinguish between them. And they all have the same amount of shielding. And if there is a full subshell or a full subshell, it's going to be the same for all of them because they all have the same number of electrons in the same shells. So the only difference between them will be the number of protons. So this will be the only factor that's going to affect the ionization energy if the elements all have the same number of electrons. So all we have to do really is focus in on the number of protons that we can use to compare these. And as long as we know the symbol of the element, we know the number of protons. Oxygen 8, fluorine 9, sodium 11, magnesium 12. So that will be the order. As we increase the number of protons, we increase the charge attraction. And the other factors are important, but in this particular example, they're all affecting these four ions the same because they have the same number of electrons. So the number of protons is the only difference between them. More protons, increasing the charge of the attraction, we have an increase in ionization energy because it's going to take more energy to overcome that attraction and knock an electron out. In fact, all four of those do indeed have a noble gas configuration. So all four of those are going to have pretty high ionization energies because if they already have a noble gas configuration, it's going to be hard to break that up. But since they all do, it's not going to be a way to distinguish between them or rank them with respect to one another.